days, we were looking at equations, and we were given the value of the variable. We were told if b equals 5, is that a true sentence? Is that a false sentence? That's how we've been working on it the last couple days. Today we're going to look at addition and subtraction equations, like b plus 2 equals 5. But now, we don't know what b is. Our job the next couple days is for us to figure out what is the value of the variable that will make that equation true. And we're going to have a major flashback Friday to Mod 4 Day 1 in today's lesson. Now, I know you can all solve b plus 2 equals 5 mentally. Remember that we always start off with simpler equations so that we can learn the steps. Yes, we want to know what b equals, but right now what I'm really teaching you is the step and the process that you're going to use, because eventually we're going to get into bigger numbers, more complex equations. So we're using easier numbers to learn the steps and practice the steps so that we have the steps down so that we could apply them to bigger equations. So just bear with me, even though you could solve these using mental math, my goal isn't what is b, my goal is to teach you the process, okay? So that's why we're starting with these easier numbers. So let's take a look at this example on the board. It's not in your notes, so you're just going to put your pencils down and follow along with me. We're actually going to look at two methods today to solve these equations. One method is tape diagrams. The other method is using algebra. And then what's so cool about algebra is that you have a way to check your work to find out if you made a mistake or not. So if you show all your steps and you show all your work, it's pretty easy to get 100 on a full credit on this, because you get to check it to see if it's right or wrong and hopefully go back and find your mistake. All right, so first of all, a plus 2 equals 8. So first we're going to draw that as a tape diagram. So 8 is my total quantity, so there's my tape diagram for 8. That's that. Now that is equal to that. So I'm going to draw a tape diagram the same size, but instead of writing 8, I have 8 plus 2 because those are both equal. A lot of this today is going to look very familiar. So what we've been doing in the first 26 lessons is laying out all the ingredients. Today we bake the cake. They're all going to come together. They're all going to come together today, and you're going to see why we've been doing all of those different steps. So this is going to look very familiar. So really, you're learning nothing new. We're just mixing all the ingredients to make a really yummy algebraic cake. So now I brought this down. But now what I'm going to do is take that 8 and break it off so that it matches. So here is a 2, and here is my 2 from here. So if a plus 2 equals something else plus 2, and I know that my total is 8, what is this going to be? 6. So I see that a equals 6, and that was my goal. My goal was to find out what is a. What is the value of my variable a? So does everybody see where that came from? I took my 8 and I broke my 8 into 2 and 6. So if I chop those off, what am I left with? A equals 6. Yeah. So let's try some together. So in your notes, we're on the top of page 118. Now when you're setting up in your notes, I want you to visualize 3 columns. Okay, because here first we're going to use a tape diagram. Then we're going to solve using algebraic method. And then, very important, the directions are telling us to check. Okay, we have to read the directions. Now, what's kind of nice on your homework tells you when to use the tape diagram, and it tells you when to use algebraic. So 1 through 5, it tells you which method to use. I think 6 and 7, you have to find the student's mistake, and then the last one is matching. Okay? But for today in class, we're going to practice both methods for every single one. And on your homework, you have to check also. The directions tell you to check on your homework. All right, so first let's start with our tape diagram. I have here B plus 9, and I know that equals 15. Now, I don't know if B is larger, God bless you, or smaller than 9. So it really doesn't matter if you make the B smaller. It doesn't matter if you make the 9 smaller because we don't know. Remember, so we don't use that visual as a cue. Not Q, the letter Q. Q, like a clue, C-U-E. So now let's take our 15 and break it up so it matches our first one. So here we have my first bar. I'm just drawing it again. B plus 9. 9. So 9 plus what will give me that total of 15. That's what I did. That's my 15 bar. I just drew it. Six. So now I see here that if I chopped off my 9s, B equals 6. Now, I'm not going to lie. I like the tape diagrams because it visually shows you how it's equal. But the tape diagrams rely on mental math. You have to be able to figure out what plus 9 equals 15. So when we get into bigger numbers, tape diagrams might not be your friend. So that's why I'm going to show you the algebraic method. If your homework tells you to only do the tape diagram, at this point you would jump over to your check to see if it was right. But I'm going to press pause on the check, and first we'll do the algebraic method, and then we'll do our check after that, okay? So now let's do the algebraic method. The first step in the algebraic method is to rewrite the equation. B plus 9 equals 15. Now, I remember way back, lesson 1. I think it was lesson 1. It was really early on in the unit, the module. Remember here, we're trying to find the value of B. We want to find the identity of B. So what did we do way back when I wanted to know the identity of B? If I have B and then I add 5, what do I have to do to get my B back? Right. Do you remember that?
Yes.
Way back, I think that was lesson 1. It was lesson 1. So if this was addition, we had to use the opposite operation. So the opposite of addition is subtraction. Does anybody remember what that's called instead of opposite operation? What was that called?
Inverse.
Nice. Inverse operation. So algebra relies on the inverse operation to solve. So we're going to find the identity by using the inverse operation. So if that's B plus 9 minus 9. But hold on a minute, I have this equal sign. Imagine a scale. If I take 9 off of this side of the scale, are they equal anymore? Or on a seesaw, if you take 9 pounds off of one side of the seesaw, is it equal anymore? No, someone's going to go flying. So what do I have to do to keep these equal? What did I do down here? to keep them equal. If I take away 9 on the one side, I have to take away 9 on the other side. Okay? So b plus 9 minus 9 gives me my b back. I have my identity. What is 15 minus 9? 6. So I got the same answer as with the tape diagram, but it's a little easier on the mental math. So if these are some really big numbers, I can see what the operation is right there. So now we want to see if this is a true statement. Let's check, does b really equal 6? So this is where yesterday's lesson comes into play. Yesterday we were replacing letters with numbers to see if they were true. So for our check, the first step is to write the original equation, b plus 9 equals 15. Now if b equals 6, I replace b with 6, bring down the rest of the equation, use my order of operations to solve. Does 15 equal 15? Yes. So when b equals 6, that made it a true statement. Now suppose I got 16 equals 15. That means that's not equal. That means I made a mistake somewhere. So if both sides of the equal sign don't equal on your check, that means you made a mistake somewhere and you have to go back and find it. All right, let's try another one. We're going to work left to right again. Make 3 imaginary columns on your paper. So first we will solve using a tape diagram. So I have 12, and then I have 8 and C. I don't know if C is larger than or less than 8, so I'm just guessing when I make the C box smaller than the 8. It doesn't necessarily mean that C is less than 8. So don't use the size of the boxes as a clue as to the answer. Now let's redraw it, but instead of making 12 a whole number 12, I'm going to draw it so it matches the other one. So what is that going to be so that it equals 12? 8 plus what is going to equal 12? 4. So C equals 4. They match. Any questions on where any of those numbers came from or how I drew anything? Now let's try it algebraically. Write the original equation. I don't want C plus 8. I just want the C. So how am I going to get rid of that 8? How am I going to get rid of that 8? Right now, 8 is being added to it.
So you subtract.
Right, so whatever I do to one side, I have to do to the other side. I have to subtract 8 from both sides because I have to use that inverse operation to find the identity of the variable. So now I'm going to solve both sides of the equation. I'll work left to right. So on the left side of the equal sign, 12 minus 8 is 4. 8 plus C minus 8 is, so I got the same answer. Both methods gave me C equals 4, but I want to make sure that it's right. The directions told me that I need to do a check. So for my check, I always write the original equation. If C equals 4, I'm going to rewrite it, but replace C with 4. Now I'm going to solve both sides of my equation. On the left, I just bring down the 12 because there are no operations to do. On the right, 8 plus 4 is 12. That's a true statement. So because that's true, I know that C equals 4. If that was 12 equals 14, 12 does not equal 14. So that means C does not equal 4. So it means I made a mistake somewhere. Maybe my mistake was in the check. Maybe my mistake was in my algebra. Maybe my mistake was copying it wrong. But you still have to go back and find it. Now, 2A. Why is this one different? This one is subtraction. I'm going to work left to right, but your page is set up so you can do the tape diagram on top, algebra in the middle, your check on the bottom. So your paper is A to C, top to bottom. I'm just going to work left to right so it's all on the same screen. So first we draw our tape diagram. The full quantity that I have is D. That's what I have. I have D. Please write this. So now for my next step, if this whole thing is D, so D minus 5. So there's my whole D. I'm chopping off 5 here. So this side, D minus 5, what does D minus 5 equal? Right. D minus 5 equals 7. So that means 5, that's 7. So what's my total? 12. So D equals 12. God bless. I knew this was 7 because it tells me right here. D, take away this 5, gives me 7. So now let's check algebraically using inverse operation. So if that's D minus 5, what do I have to do to get the identity back? Add 5. So if I add 5 to one side of the equation, I have to add 5 to the other side of the equation. Now I'll follow my PEMDAS rules and solve both sides of the equation. So on the left, D minus 5 plus 5 gives me D. Now I look at the right side, 7 plus 5 is 12. I got the same answer, D equals 12. So now let's use check to see if we were right. All right. So for our check, D minus 5 equals 7. D is 12. 7 equals 7. So that is a true statement. Because 7 does equal 7, now I know that D equals 12 was correct. They can always be true? Yes. If you didn't make a mistake, yes, they always will be true. All right, let's try another one. Do you want to try an addition one or a subtraction one?
Subtraction.
Let's do one more subtraction. So B, F minus 10 equals 15. So here, my full quantity that I have is F. I'm taking away 10. So F minus 10 equals 15. So that means that's 10, and that's 15. So that means it is 25. You have to think about what you have and what you're taking away. So now to solve it algebraically, I'm going to do the inverse operation, so I have to add 10 to both sides. So on the left, that gives me F. And on the right, that gives me 25. So now to check it, I write my original equation. I replace f with 25. I do the operations or the math on both sides. And good thing it checks that's true so that I know I did everything correctly. So on your homework, make sure you have your check no matter which method you use. If you have to do a tape diagram, then you jump straight to your check. Excuse me, I'm speaking, please don't close your binders. It makes noise, it's distracting, and then you're not listening. If you want to do all the methods for your homework for practice, you can, but you don't have to. Just follow the directions carefully.